So I'm going to start in going through this by just showing how to do each part, like how each part is going to work, and then we'll talk about one or two calculator things. So part A says find all values for which the speed of the particle is 2. So we need to make sure that we have an equation, an expression. Well, speed is absolute value of velocity. So because speed is absolute value of velocity, then we need to know when that function equals 2. That's what we need to know. And then we're going to have the calculator do the rest. And I'll show that in just a minute. Part B. Write an expression involving an integral that gives a position function. So the position function, since we have velocity in front of us, the position should involve an integral of velocity. And since we're starting at 0, we're going to go from 0 up to wherever we want the position at. That tells me how far away we are from where we started. Right? That tells me how far we went. So then I need to also factor in where we started. Well, that's s of 0 being 10. And so we're going to say it's 10 plus this integral. So the position function is saying start at 10 and then go this far. And then we want to find s of 5. S of 5 is 10 plus, we're just plugging in 5 for x. So that means that 5 goes in that top bound of the integral. And then that's where the calculator is going to come in. And keep in mind, you can write v of t. You can write that function. You don't have to write this big long equation every single time. It's v of t, so we can just use v of t to refer to it every time we need to refer back to it. Part C. Find all times that the particle changes direction, justify your answer. Anytime it says justify your answer, I usually start with the justification, because then my calculus thinking is done, and then I can just let the calculator do the rest. So we are going to find where the particle changes direction. It changes direction. That is when v of t changes sign. So when v of t changes from positive to negative or from negative to positive. And we'll probably be specific about which one that is. So we'll say v of t changes from negative to positive here, and it changes from positive to negative here. That's part C. Part D is the speed increasing or decreasing. That's a speeding up or slowing down question. So that means we are going to compare at 4. We're going to compare the velocity with the acceleration. Well, acceleration is going to be the derivative of velocity. So we're going to compare those and compare the signs of them. And that's where we'll let the calculator step in. So now let's talk about the calculator stuff. So part A. In part A, I want to know where the absolute value of velocity is 2. So here's my velocity graph. So here's what I'm going to do, is I'm going to turn y1 off because I'm not interested in it. I'm not interested in velocity right now. I'm interested in the absolute value of velocity. So I'm going to turn y1 off. I go over to the equal sign here that's highlighted, and I hit enter. Click on it, and it's not highlighted anymore. Okay, and then I have 2 things that I want. I want graph of absolute value of velocity, and I want the graph of 2. And I want to know where those 2 graphs intersect. So that's what we're going to use to find this. It's not the only way to do it in the calculator, but it is a way to do this. Absolute value of my velocity functions in y1. So I'm going to call up my y1 function, alpha trace, in y1. And then the other function I'm interested in is 2. So there's 2. And then I'm going to tweak my window because I know that for part A, I'm interested in the interval from 2 to 4. I want to know when this happens in the interval from 2 to 4. So I'm going to narrow my window a little bit. Yeah, probably not there. So instead of going there, I want to go from about 1 to about 5. And that'll capture from 2 to 4. And then I want to know where when it's 2. So let's go from -5 to 5 on y. And let's graph. So this is graphing absolute value of velocity. And now here comes 2. And I want to know when those 2 are equal. In other words, I want to know when these 2 graphs intersect. So the way that I can do that in the calculator is we are going to go second, trace, that's calculate menu. And it's going to say, what do you want to calculate in this graph? Well, I want to know where these 2 graphs intersect. So calculate intersection. And so it's going to ask where do you want the intersection to be? So you're going to hover right over where the intersection is and hit enter. 1, 2, 3. And there's your first intersection. So we'll round that to about 3.128. We're going to go to 3 decimal places on all these answers. Then we can do the same thing for the other point. And I'll show where the other point is in just a second. But people asked about some of the other parts. Remember, for part B, you're going to need the integral. So you're going to go math 9 for f and I and t, and then put in the thing that you want. And then in part D, you're going to want the derivative. So you're going to need math 8 for underive, and that's going to be, you're going to want that derivative at 4. But let me go to part C, which is we want to know where the velocity is 0 and changes direction. And we want to know that from 0 to 5. So I'm going to adjust my window again a little bit. So since we want from 0 to 5, I'm going to broaden my boundaries a little bit. And then make my graph. So I'm interested in the points where it changes direction. So it's when the graph hits 0 and changes from negative to positive or positive to negative. So 1, 2 places from 0 to 5. So I will find one of them and leave you to make sure you can find the other. Calculate. Same menu we did the intersection, but this time I want a 0. And it's going to ask for left bound and right bound. I want to focus in on, this looks to be about 2/3. So for my x coordinate, I'm going to get to about 2/3. Left bound, so it's asking you to kind of zoom in on where the 0 is. So pick a point to the left of the 0, hit enter. Pick a point to the right of the 0, hit enter. So you told the calculator, I want the 0 that's in this little window here. And then where is it? It's about here. So 0.536 is where v of t changes from negative to positive. And then you do the same thing for the other point to figure out where it changes from positive to negative. All right. So let me just show you the rest of the kind of answers for this problem so that you can check your work. And I'll talk about how it was scored as well. If you'd recognized that speed was absolute value of velocity and checked where that was to, if you wrote that down on your paper, then you got a point. These free responses are always 9 points total. And then a point for getting the answers out on your calculator. Part B, a point for the expression of S of t, and then a point for plugging in 5 and getting the answer out. A point for recognizing we want to know where v of t is 0. And then 2 points for each point with the explanations that one's changing from negative to positive, one's changing from positive to negative. And then finally for part D, you should have gotten that the particle was speeding up. Speed was increasing because velocity and acceleration were both negative. So the particle was traveling to the left, and it was also being pushed to the left. So those were the coordinates on the calculator.